Hello, my name is Brendan O'Farrell. I'm the president and founding partner of DCN Diagnostics.
And I'm Pat Vaughan. I'm the Chief Operating Officer here at DCN, and I run all our development programs. So a CLIA lab, obviously that's a term we hear a lot at the moment. So these are labs that are specifically certified to run laboratory tests. So they have been set up, they've been validated, they follow a quality system so that you know that that the assay is being run correctly and the results are generated with traceability.
The current generation of RT-PCR based tests require a CLIA laboratory in order to run them. So they require infrastructure, they require trained personnel. It takes time simply to get a sample from the point of sampling to the laboratory, to run the assay, to get results generated and certified and back to the patient. So at this point in time, when we're hearing about bottlenecks, if you will, in the testing protocols, it's not necessarily the test itself, it's simply the process by which we have to get the sample, get it tested and get the result back. So that's why there will be a tremendous advantage to moving to true point of care testing, where we can actually test in the moment the sample is tested and generate results very quickly on the spot. The other thing to consider is sampling, right? So right now, people are being sampled using swabs, so a nasal swab or nasopharyngeal swab, and those samples are being sent to central laboratories for testing. It's a time-consuming process and it's a difficult process. It's an uncomfortable process to get that sample. When we switch to serology testing, that becomes a finger prick or a blood draw from a tube, and it's actually quite a bit more comfortable than a nasopharyngeal swab, and it can be a more effective sample in many ways because it's easier to get a high quality sample. And it allows for real drive-through testing, real point of care testing, whereas the nasopharyngeal swab linked to an RT-PCR test requires infrastructure, requires a laboratory. So really what we're talking about at this point in time is drive-through sampling, not drive-through testing. Yep. But hopefully at some point in the near future we'll switch to real drive-through testing.
Yeah, absolutely. So with rapid tests where you're talking about 10-15 minutes waiting for a result. So we see on TV these people lining up in cars to be have the drive-through testing. Here now they'll not alone will they sample them, now they'll run the test immediately on site. You'll probably just pull to the side and in 10 minutes somebody can come back to the window of your car and give you the result, and then you can be triaged appropriately.
And in terms of the technology that's used for that kind of testing, the most commonly deployed assay format is a lateral flow assay. If anybody's ever been to a doctor's office to have a strep throat test, or if anybody's ever taken a home HIV test, for instance, it's that format of an assay where we're doing for something like this, it'll be a finger stick. We'll be taking a sample on the spot, running a 10-15 minute assay, interpreting a result either visually or using a reader system like even a digital, even a camera phone, with appropriate apps on it, and we can actually generate a result on the spot, track the results digitally, do all of the epidemiology that needs to be done, and generate much more efficient mass population testing that way.
Yep, and from a supply chain point of view, these rapid tests can be generated. It's very straightforward to manufacture hundreds of thousands, if not millions of these. As you said, for be it HIV testing or strep throat or whatever. So, and again, take the instance of malaria in this world. There are millions and millions of these tests produced annually by many, many different manufacturers as well. So these are tests that can be turned around and produced in large numbers very effectively.
Exactly. So once the infrastructure gets up and running, the time to develop a test like this is on the order of a few months. Once the reagents, the antibodies are available, the manufacturing capacity exists in the world. Malaria testing, for instance, is done, 300-400 million tests a year. So the manufacturing infrastructure exists to produce those tests in very high numbers. So tests will be quickly deployed. There is just a lag time while the reagents get developed in order to make them work.